All right, everyone. Today we're going to look at how we can go from the beginning of the scientific process and take one step farther, moving on to set up our tests. And so we're going to focus on identifying variables. We've talked about making observations and that leading to questions, but there is kind of a half step between questions. If we make a good testable question, moving from that to developing a hypothesis, outlining how we're going to do our test. And so we talked about this a little last week. Identifying variables becomes really important. It's key to clarify, what am I really testing? And for those of you in advanced, we're looking at phase one. Do you understand? What am I comparing? What am I measuring? You get one set of independent variables. You get one dependent variable. And a lot of times people, when they're making their own tests, want to get all kinds of information. You're looking at, um, this and that and another thing, and you're trying to compare lots of different things, and you're measuring lots of different things because you're interested about it. And it's okay to make more observations, but you need to structure and outline your test where there's really only one thing that you're measuring to determine, did you learn something? Sorry. For example, what if I was rolling a bowling ball and a soccer ball down a hill? And I said, well, okay, independent variable. I want to compare bowling balls and soccer balls. And I had to set up my dependent variable. What am I measuring? And I thought, well, I kind of want to know, does the ball roll farther? But I also want to know which one rolls faster. Well, it gets a little bit confusing if the soccer ball rolls faster, but the bowling ball rolls farther. Well, then which one really won the test? We get confused and it leads to faulty analogies. So it's important that we structure our tests where we go, there's the one thing that I'm measuring to determine what my results are. And I'm only comparing one thing. It's okay to compare soccer balls and bowling balls, but if I also put a soccer ball on the grass and a bowling ball on the road, now I'm not sure what's really causing things. And so everything else needs to be controlled. So that's why controlled variables can have many, while the other ones only get one. So, review from last week: independent variable, what you're changing; dependent variable, what you're measuring; and controlled variables, what you have to keep the same. Let's look at some examples. Here we have a test, and today we're going to focus on plants because we're about to start our clover project. Here we've got a plant, say a beanstalk, and our independent variable is the thing that you get to change. My best advice that I've been giving students is pretend you're the scientist. Don't look at this as, well, someone else is doing everything. They're all making all the decisions. When you put yourself into this, you go, well, what do I want to change? What am I going to set up? And in this example, your independent variable is the thing you get to compare or change. So looking at this picture, what's different? Well, obviously, we've got some green drops here, but none here. We've got more and more. It's the amount of fertilizer. Independent variable starts with the letter I. I can choose how much fertilizer to put on. It's my test. I can do it any way I want. And I just so choose to go with 0 drops, 2 drops, 4 drops, and 6 drops. If you were running this test, you maybe would choose 0 drops, 20 drops, 40 drops, and 60 drops. Maybe you want to see a bigger difference. Maybe your research leads you to go, the amount of fertilizer isn't what I want to change. It's the type of fertilizer. Again, independent, you get to pick it. You're free to choose whatever you want to test. The dependent variable, we've got a lot of options. The dependent variable is the one thing you measure. Now, when I say measure, I mean measure to get the results. Clearly, the independent variable we had to measure. We had to measure 2 drops, 4 drops, 6 drops of fertilizer. But that's not the type of measurement I'm talking about. I'm saying, what is the measurement that will give me my results? Who's the winner? So here, we have lots of things that we could choose to be our dependent variable. There, now I'm on the right slide. So dependent variable, what's the winner? Well, we have to measure or count something to get to our results. So we could measure how tall the plant grows. Maybe we measure how many leaves grow on it. Maybe we calculate surface area of those leaves. Maybe we measure how many days does it live before the plant withers up and dies. So we can measure time. As long as it comes up with the number, and that's what we're basing our result on, and it should be in our scientific testable question, then that's okay. Lastly, we have controlled variables. These are things that keep things fair. Controlled variables, like I have 3 kids, and when we play a game or I'm cutting pizza at home, things have to be fair. You can't just cut them any shape or size. We can't just let the same person go first every time when we're playing a game. So you get the concept of fair. So if we were running this test, we had to think about what are some things that would make it fair. It would not be fair if I gave just one plant, say the plant that has 2 drops of fertilizer, if I put that in sand and the other 3 pots were in black dirt. That's not fair. It wouldn't be fair if I turned the light on the 0 drop of fertilizer water on for 5 extra hours. So the amount of light that it gets has to be the same. The amount of water would have to be the same. The amount of soil, not just the type of soil, but we can't have 3 centimeters of soil on the 0 drops of water and 40 centimeters of soil on the 6 drops of water. It just wouldn't be fair. So all of these things need to be kept the same. We call them constants or controlled variables. All right. I'm not going to play the video, but if you wanted to go back into the notes, there's a short video and a link to a Mythbuster video. And so that is an option if you want to see some more examples. And then here's a question that would follow up with that. Let's move on to some more examples. Again, sticking with plants today, which is totally fine, but this works with any type of experiment. Here, we're looking for different colors of light. So that's our independent variable. So hopefully from the nice pictures, you can see, hey, look, the only thing that's different about these 2 things is the color of the light bulb. And we're saying we want to measure the plant height. How far does it grow? Now, I don't get to choose how tall it grows. That's what I'm measuring to get my results. So that's our dependent variable. But amount of water, how long we run the test, type of soil, temperature of the soil, all of these things would need to be kept the same. Time of day we run the test. These are all controlled variables. Last example, hopefully you're catching on. I'm going to give you a little pause. Look at this picture. See if you can identify what the independent variable would be. Again, the independent variable is the thing that's changing. So my advice to people who've been struggling with the homework today is put them in a lineup. Everything about the test should be exactly the same except for one thing. That one thing is your independent variable. Hopefully you picked out that the independent variable was the type of liquid: cola, juice, water. Now, what's my dependent variable? Secret, there's a metric measurement tool somewhere in there. So if you sometimes a little help to help you figure out what the dependent variable is what metric tool am I using to get my results? Not just a metric tool you're using at all. We might need a metric, a graduated cylinder to pour the right amount of liquid in. But here we've got a ruler. That's simply there for my results. So length that the plant grows would be my result or my dependent variable. And lastly, controlled variables, anything that needs to stay the same. Would the amount of liquid poured be a controlled variable? Think about that. We know that the independent variable is the type of liquid, but would the amount be a controlled variable? Turns out, yes, it is. It wouldn't be fair to put 20 milliliters of Coke in and 80 milliliters of water. That wouldn't be a fair test. We want to put the same amount. Even though the liquids are different, and that's our independent variable, we have to put at least the same amount in. Thus, we would need other things like the size of the bucket we're growing in, the amount of days that we run our test for, the person that's running the test. All of these things would need to be kept the same. All right. The next step is going to be to create a hypothesis. Now, creating a hypothesis is a little bit trickier. And to do it, you really need to identify both the independent and dependent variables. We leave the controlled variables out of this. And we're going to spend Thursday looking at how to do this. Last year, you probably learned that a hypothesis is an educated guess, which is true. Problem is sometimes people think they did a bad experiment if they didn't predict correctly what's going to happen. And that's really not the case in science. We learn by looking at all the possible outcomes and then seeing which one is correct. So last year you probably learned something about if, then, because. That's not wrong. That's a totally acceptable way to write a hypothesis. However, when I worked in a lab for 12 years, I never did if, then, because. It's kind of a stepping stone to learn, hey, this is where the different parts go, and these are the things I'm thinking about. So on Thursday, we're going to learn a better way to look at a hypothesis, and we're going to learn what's called a null hypothesis. But we'll leave that for Thursday. So go in and complete the form. Be sure if you get anything wrong, look at the feedback in the form so you can see what questions you got wrong and learn from those mistakes. That's the most important part of that homework today. And you can always come back and look at this video again or look at the notes without the video. All right. Good luck with variables.